Parity is, by definition, a function whose being even or odd provides a check on a set of binary values. Alright, I think we're done here. Like and subscribe. Bye. Time to eat my potato soup.
Whoa, hold up. You're not doing the explaining thing right. Why don't you start with explaining why we need this technology?
So this video relates to RAM and how data is transmitted and stored in a reliable manner. The concept you learned today, you're going to be able to apply to hard drives, you're going to be able to apply to communications, and what we're going to focus on is, the volatile memory storage. So RAM can break in one of two ways. One is a hard error. A hard error is something that you cannot recover from. I'll give you an example of a hard error right here. Wow, they're really tough, aren't they? You can't exactly Well, it's probably broken anyways. That's an example of a hard error. If I was to electrocute it, melt it, or snap it in half, that is an error that we cannot fix. We would have to get either a new product or remake the product. So when a hard error occurs, you cannot continue to use the device. The RAM will not work, the hard drive will not respond, or the communication line will be permanently broken until you fix it. And it usually relates to a physical thing. There are other errors though. These are called soft errors. These are errors that occur during the device running. The device will appear normal until they happen. So an example of this would be if I had a wireless mouse and I put a brick wall and then we had a soft error. Well, my wireless mouse still works, but that wall is interfering with communications. This is a soft error, even though the brick wall is hard. That's probably not a good example. Soft errors in RAM occur from a lot of reasons. It could include the speed of the RAM is too high, the timings are off by a little bit, the RAM is getting really hot and it's not able to store data in a reliable manner. It could be that the communication lines are just not great, or maybe you didn't see in your RAM correctly. There are also two other things which we'll get into, which are kind of a big point of focus for this, and why we look at these errors and why we correct for them. In the early days of its invention, RAM was very prone to errors. This was due to alpha particles flipping a bit. A bit is a 1 or a 0, and it would go from 1 to 0 or 0 to 1. That's a very bad thing when you're storing financial records or people's names. And these alpha particles were caused from badly sourced RAM. The RAM was actually found to have thorium and uranium in it. Kind of crazy, and don't let that worry you if you have an old computer lying around. This was way back when. You're not going to be using any of these devices today. But it was found that the errors were caused by inside. So you can stop an alpha particle with a wall or the shielding of your computer case, but these particles were happening inside the RAM. So this was fixed. 1980s, we have very nice RAM that just kind of works, but we still have errors. The errors we have nowadays and that occur in our devices nowadays are caused from cosmic rays. These are rays and energy particles that are emitted by the sun whenever it has a hiccup, and they're high energy, meaning they can pass through a lot of materials. So these high energy particles will come through your house, they'll get in your laptop, and then they'll flip a bit, and it's whoops, there's a memory error now. And this stuff happens all the time, and we just go about our lives. There was actually a study published in volume 40 of one of IBM's magazines way back when, in that a group of scientists ran a computer 50 feet under solid rock, and no errors occurred. This was crazy. Normally you would expect to see one error every 4 or 5 months, and there was something wrong there. But underground, away from, had a lot of shielding from these cosmic particles and stuff worked. Very nice. Well, that study's a thing. We can't have all of our computers 50 feet underground. That would be troublesome, to say the least. As far as memory errors are concerned, 3 different solutions have been put in place. Our first solution is not to fix it at all. Take, for example, my phone. If my phone has a memory error and it shuts down due to a bad instruction, I don't care. I will restart the device and go about my life. It's the same for my music player, Same for my laptop. Same for whatever else I'm working with. The idea is that it just doesn't matter. Yeah, it's bad to have it crash, but once every few months, I can live with that. It'll probably crash way more often due to other things such as bad programming or just bad construction of the device. This type of memory is called non-parity memory, meaning that there is no correction, there is no checks, it just happens. The next type of memory we have is parity checking RAM. Parity checking means that it is able to detect an error, but not able to correct an error. And I'll explain how this works in a later video. This was really common from about 1970 to 1990 to have parity checking memory. Although, the downside is that it didn't really fix anything. The computer would just pop up with a screen saying a parity error has occurred, and it advised that you save your work and shut down the system. Well, it's able to detect that error, and when you have invalid memory, you don't want to keep running that. Instead of saving, something might delete. Instead of writing the letter A, it might write the letter B. Just weird stuff can happen in the operating system, and that could change like some core running code. If something changes in there, that's bad. So normally you would just save your workbook under a different file, shut down the system, restart it, and go about your day. Now I did mention that that doesn't really fix anything. And if I was running a server that hosts 100,000 people's bank records, well, I don't want stuff going wrong. I don't want to have to do a cross-check every time an error occurs. I want the error to just fix itself. I don't want any downtime for the server. So to fix this magical need, error-correcting code was developed. And error-correcting code works on the hardware level. It's often abbreviated ECC, so you'll find an ECC Ram chip. You have to have an ECC compatible processor, and that is able to correct errors on the fly most of the time. I think 98% of the time. It's good. The other 2%, it'll at least let you know. You'll only be able to find ECC support on some higher level processors nowadays. Think the Ryzen Threadripper series, the AMD EPYC series, EPYC, and then there's Intel Xeon, the server chips. So these chips have a memory controller built in that is able to work with that ECC code, and it's able to check errors on the fly. And in some later videos, I'm going to explain how this works. But for now, just knowing that ECC RAM is out there, it's really cool, and it is kind of pricier. So this would only be good and viable if you're running a server, if you're, time is money situation here. So there's three types of memory. Non-parity, which means it doesn't fix it, it doesn't know. Parity, it knows, but it doesn't fix it. And ECC, which means that it detects it and corrects it. Thanks for watching, and join me for the next video as we explain how these processes work. Like and subscribe. Bye!